Caffeine as a reinforcer, which is why you return again and again. Caffeine also increases the release of dopamine and acetylcholine, both of which are neuromodulators. So let's talk first about caffeine as a reinforcing agent. Again, this was first most beautifully demonstrated in this study on honeybees, where the bees prefer nectars that contain caffeine. And that all makes perfect sense in terms of the ecology of bees and flowers that contain nectar. There's an advantage, at least in terms of adaptation, that the flower benefits because of distribution of things from the flower, which is good for the flowers, and the bees benefit because they're getting food. And so there's a kind of a symbiosis there. But with humans, we're consuming caffeine-containing beverages for our sake. I don't think we have it in mind, nor do the bees have it in mind, frankly, that we're trying to preserve the plants that provide the caffeine. I think we would all suffer, or I should say 90% of adults would suffer greatly if all the caffeine-containing coffee and tea plants were gone, certainly. But most of us are not consuming coffees and teas and caffeine-containing foods because we're thinking about the plants they come from and we want to help those plants. We're thinking about how we want to help ourselves. And yet the point of the reinforcing effects of caffeine are that they are largely subconscious. We are not aware of them. Now, you might say, no, that's not true. When I drink caffeine, it makes me feel really good. So I'm aware that it makes me feel good. In order to illustrate how reinforcement really works, let me give you the counterexample, which would be an aversive agent. So we have reinforcing agents and we have aversive agents. Let's say that there were compounds in nature that exist in plants that are aversive, and indeed they are. And let's say that these compounds were present at such low concentrations that you couldn't taste them. Let's say you wake up in the morning and you go to your refrigerator and you open it up and you are thirsty, and so you reach for a nice, rich red containing beverage in a glass jar. Maybe it looks like cranberry juice or something of that sort, or even a nice clear glass of water. It looks like a jug of water or a glass of water, and you drink that. Tastes fine to you, maybe even tastes great to you. And then let's say about 30 minutes later, you feel a little queasy, you feel a little off, you feel like going back to sleep, you just don't feel very good. You don't know why, but your nervous system is a predictive machine, and it has a process in which it integrates backwards into your immediate experience that preceded that not so good feeling. We can reliably say that there is a much lower probability that the next day when you wake up, that you would reach for that same beverage or for that same container even. And maybe if you're in a novel environment, maybe you're staying in an Airbnb or a hotel or something of that sort, you might even find that you don't really like the kitchen in which you consume that beverage in the first place. Now, you don't know why. And unless you got very, very sick the day before, it's unlikely that you would have such a strong response that you would entirely avoid, for instance, water or glass jars containing liquids, etc. Let's say you went back to the refrigerator and you consumed beverage again, and you just didn't feel so well. You felt less good than you normally would. Well, even without any ability to taste what's in that beverage, and even without any understanding of what was happening to you at a conscious level, there is a very, very high probability that you will avoid drinking that particular beverage, and certainly at that location and in the same volume in the subsequent days. That's just the way that aversive agents work, and they work by way of activating neurons in the gut that communicate with areas in the brain that give us this feeling of queasiness. And for some of you hearing this, that pathway and that association with times in which you felt queasy and as if you wanted to vomit is so powerful that you might even be feeling some of that symptomology now. For certain people, that's going to be increased salivation, which precedes vomiting. We know that there's a class of neurons in the brain related to an area called area postrema that actually stimulates vomiting. And if I keep talking about this, I'll probably feel like I want to vomit. So I'm going to move on from this in a moment. So when we ingest caffeine-containing beverages and foods, it's the exact opposite scenarios to what I just described. Caffeine, as a reinforcer, makes us feel slightly better or a lot better in the immediate minutes and hours after we ingest it. So it's acting as a reinforcing agent, not just while you're under the effects of caffeine, but for the things that preceded the ingestion of caffeine. which is why you return again and again to caffeine-containing beverages such as coffee and tea, or maybe even foods that contain caffeine, even if the taste of those foods is not something that you would otherwise consider especially delicious. In fact, most people, when they take their first sip of coffee or tea or other caffeine-containing beverage, they find it to be very bitter, and that's not because of the taste of caffeine. It's because of the taste of the beverage itself, independent of caffeine. However, when caffeine is present in there, they come to prefer that taste over most all tastes. In fact, they will, as I mentioned earlier, will invest a lot of financial resources and time and energy to make sure that they get that beverage. What they're trying to make sure is not that they get that taste, but that they get the caffeine. It is that positively reinforcing. And the taste, therefore, takes on new significance, new meaning, and we come to associate it as positive. And in fact, most of us, including myself, love the taste of espresso, love the taste of coffee, love the taste of yerba mate, even if the initial taste, the very first time that we consume that beverage, was either neutral or negative. And that is all because of the reinforcing properties of caffeine. And then, of course, there are the more direct actions of caffeine, that is the faster actions of caffeine. And just to list those off again very briefly so that you have them in mind going forward, caffeine also increases the release of dopamine and acetylcholine, both of which are neuromodulators in the forebrain, which increases clarity of thought and your ability to rule switch, your ability to move from one context to another and change and understand the rules of engagement, social engagement, physical engagement, mental engagement, and so forth. And as I mentioned before, caffeine also increases the number of dopamine receptors in the reward pathway such that any good thing that happens to you, any positive experience that you have, will have a more potent effect on your feelings of well-being. And last but certainly not least, caffeine acts as an adenosine antagonist. It reduces your feelings of lethargy and fatigue and your desire to sleep by parking in the receptors for adenosine and not allowing adenosine to have its pro-sleepy, if you will, effects on your brain and body.